Hey guys, welcome back. Here's another video on this time molar mass calculation. And if you scroll down, using molar mass, how can we determine how many moles are in a certain grams of something? Okay, so to start us off, let's go ahead and really talk and discuss what exactly is a mole, right? So 1 mole, sometimes it's abbreviated as MOL, it is 6.02 times 10 to the 23 many things. Okay. Now, I call this a scientist's dozen. The reason why I say that is because we know that a dozen of something means 12 things of something, right? A dozen of eggs, a dozen of students. However, in chemistry, we use this unit of measurement called mole. Now, it is a big, big number. And the reason why we're using moles is because in chemistry, we're dealing with very, very large and small numbers, right? That is why we need to group them in a way that we can actually easily do calculations, okay? So let's see. What exactly is molar mass? Molar mass is how many grams of something do you need in order to have 1 mole of that substance, okay? Cool thing about periodic table is that it is organized in a very awesome way, right? So here's 1H1.008. That is hydrogen. Okay, the number below the symbol H, right? I'm gonna go ahead and highlight this part in blue. Let's go. Okay, so that we know that it's the average atomic mass, right? That is simply put weighted average among the different isotopes of hydrogen, right? However, it actually has another use. This number actually is the molar mass of this element. Okay, so what does that mean? It means, okay, if I had 1.008 grams of hydrogen, that would give me exactly 1 mole of hydrogen. Okay, so that could be, the molar mass could be found on every block in the periodic table. Okay, for example, if I wanted to know, okay, copper, what is copper? Well, long time ago, I think before 1982, coppers were made from pure copper. And if you look on the periodic table, the number below the symbol, it's going to give 63.5. Okay, now which means, okay, if I had 63.5 grams of copper, that would mean that I have 1 mole of copper. So that's a lot of copper, right? A lot of copper atoms. Okay, so with that in mind, we're going to jump right into doing some calculations. Okay, so these fractions that we just found through the periodic table, these are called conversion factors. Okay, they're sort of like scientific laws. They cannot be changed, altered. They are always constant. They stay the same. Okay, which means that if I had exactly, again, 1.1008 grams of hydrogen, that's always going to give me 1 mole of hydrogen. Okay, there's not going to be a day where you just wake up and go, you know what, I'm going to say 1.5 grams of hydrogen is going to give me 1 mole. No, it doesn't work that way. Okay, it is predefined, does not change. Okay, so now that we know what molar mass is, again, how many grams, that would equate 1 mole of something. Let's go ahead and start doing some questions based on this idea. Let's see. All right, starting with the first one, N2O6. That is dinitrogen hexa oxide, right? So let's see what we're going to have to do. Now, this is a compound, right? This is a molecular compound, which means it's not just one element, but it's actually multiple elements, all combined together, right? So let's begin with nitrogen. If you look on the periodic table, each nitrogen is going to be roughly 14, okay? Now, how many nitrogens do we have inside this molecular compound? We have 2, all right? So let's go ahead and multiply those 2 together. That's 28. Great. Now, let's move on to oxygen this time, okay? Each oxygen on the periodic table, it'll say 15.999. Now, I'm just going to go ahead and round that up to the nearest whole number, okay? And I'm just going to say that that's 16 per oxygen, and we have 6 oxygens, right? So that's going to give me 96, all right? So if you add these up, see, that's 4, 12. Okay, so 124. So that is the molar mass of this N2O6 molecular compound. So let's give it a unit, shall we? I'm going to go ahead and say grams of N2O6. Okay, that's going to give me exactly 1 mole of N2O6. Okay, so let's do a quick recap of this. If I had 124 grams of N2O6, that would give me exactly 1 mole of N2O6. Okay, all right, so that's the first question. That is how we find the molar mass of compound, element, or whatever the substance is. As long as you know the chemical formula, you are able to determine its molar mass. Okay, let's move on to number 2. Okay, I got Na2SO4. That is sodium sulfate. Okay, so there's a lot of elements here as well, right? Different kinds of elements. So first, I see there's sodium, okay? Now, each sodium is going to be roughly 23, right? On the periodic table, if you look on the block, the sodium block, underneath the symbol, you're going to see the 22.99, okay? So, or 22.99, excuse me. I'm going to go ahead and round that up to 23. Notice that I have 2 sodiums there, right? So I'm going to go ahead and multiply that by 2. So that's 46. Okay. Now, what about sulfate? Sulfate is a polyatomic ion, which means poly, many atoms, right? So we have different kinds of atoms all combined together. Starting with the first one, S. That would be sulfur. Okay, let's look on the periodic table. And sulfur, it is going to say 32. Do I need to multiply by anything? No, because there's only one sulfur. Great, so let's just leave it as that. Now, what about oxygen? I know that oxygen is 16 per atom, and it seems like we have 4 of it, right? So that is 64. Great. What do I need to do with all these numbers? I need to combine them to find the molar mass of this combined ionic compound here, which is sodium sulfate. Okay, so let's go ahead and line those up. 46 plus 32 plus 64. Okay, so that's 12, 11, 14, right? 142. So, okay, let's give it a unit again. 142 grams of sodium sulfate is equal to 1 mole of sodium sulfate. There you go. And that is the molar mass of that following compound, okay? Now, if you are unsure and you just want to make sure that you did it correctly, what you can do is you can actually go on Google and look up molar mass. Simply type in Na2SO4 molar mass, and it's going to give you its molar mass, okay? So you can go out and check yourself like that, all right? Obviously, you're not going to be doing that during class or during an assessment, so just be very careful of that, right? Okay, let's go ahead and move on to page number 2. Now, using those molar masses that we just found, how can we do some calculations? Okay, so I'm going to do an example question here that is not part of this worksheet here, but it's fine. It'll help us learn. Let's say I had 50 grams of water, okay? And I want to find out, okay, so how many moles of water is that? All right, so I'm going to go from 50 grams of water to how many moles of water does that make up, okay? So first and foremost, what you're going to have to do is find its molar mass of this water compound, okay? So H2O, okay? So there's 2 hydrogens, right? And each hydrogen is 1, approximately 1, all right? So notice that, okay, there's 2 of it, so I'm going to multiply that by 2. I should label so that you guys don't get confused. I'm going to put it to the side a little bit. So hydrogen, right? That's 2. And what about each oxygen? Each oxygen, there's 16 and there's only 1, okay? So if I add these two numbers, right, that'll give me the overall molar mass of water. So that is 18 grams of water is going to be 1 mole of water, okay? All right, so I'm going to go ahead and clean this up a little bit so that I have some space. And there you go. Okay, so now that I found my molar mass of water, I'm going to be utilizing that into finding out, okay, 50 grams of water, how many moles of water is that? Okay, so it's kind of like what we did before. Okay, we're doing the dimensional analysis, and except this time we're not using, we're not doing length mass, but instead we're using molar mass conversions. Okay, so begin with okay, here's my different color. Begin with a starting unit. Okay, what is my starting unit? Well, it's what I begin with, what I have, right? And what I know, which is 50 grams of water, okay? Now, take a look. Since I have unit of grams of water, I want grams of water down here also so that they can diagonally cross-reduce units, right? So if you look here, here's the conversion factor that I just found, molar mass, right? Which one of the two, top or bottom, has grams of water in it? Obviously the top one, right? So simply bring down 18 grams here, which means the other one, the remaining unit is going to go on the top. Okay, so let's see if I did it correctly. Let's go ahead and cancel out the units. Grams of water, great. The only unit that is remaining here is moles of water, which is exactly what I want to find here. Okay, so let's go ahead and multiply this all across, which is 50 times 1, which you don't really have to do that, right? Divided by 18, and that is 2.78. 2.78. Okay, now no naked numbers. Make sure that every number has its corresponding units. Okay, so that's 2.78 moles of water. And that's it. Yeah, that's the only unit. So what I'm going to do is bring that up here. Sorry, it got a little messy. Okay. So if I had 50 grams of water, that would mean I have 2.78 moles of water. Okay? Awesome. Okay, let's do an actual question. Okay, I'm going to go ahead and delete all this. Go away. All right. So here's question number 1, now that we've done an example together. How many moles is 2.4 grams of N2O6? Wait a minute. Didn't we just find N2O6, the molar mass? Yes, we did. So here's what I'm going to do. I'm going to copy this, and just going to paste it right there. Okay, so that is the molar conversion that I'm probably going to be using. Okay, let's begin with the starting unit. I have 2.4 grams of N2O6. Okay, now I want grams of N2O6 on the bottom here so that the units cancel each other out, right? So if you look to the left, my conversion factor here, obviously the one that has grams of N2O6 is 124, right? The top one. So let's bring it down here, which means I will have 1 mole of N2O6 right here. Okay. The units go away. The only thing that I'm left with is mole of N2O6, which is exactly what I want to find here. So that's 2.4 divided by 124. Okay, 0.019 moles of N2O6. Bring it a little bit closer like that. Okay, that's it. Okay, now this unit, guys, showing work is very important. If you skip work, that's not good. I want to see how you got your answer. Getting the right answer is really not important. the steps, the process is a lot more important. So make sure you show your work along each step, okay? Let's do one more question, one more. Let's see. How many grams is 7.3 moles of Na2SO4? Okay, likewise, if you did the molar mass conversion calculation correctly, you should have it up here as we did together just now, right? Copy that, and I'm gonna bring that down right over here. There you go. Okay, so what am I trying to do here? I'm converting 7.3 moles into, okay, how many grams does that actually make up? So I'm beginning with 7.3 moles of sodium sulfate. Okay, so what else do I have to do? My next step is that, okay, I'm trying to go from moles to grams here, which means if I have mole Na2SO4 on the top section here, I want it right underneath here as well so that the units go away, right? So moles of Na2SO4. Okay, so which one of the two, going back to my conversion factor here, contains that unit? So the bottom one, so just like that, right? Which means 142 grams of Na2SO4. Just like that, right? So multiply those two numbers across, 7.3 times 142. So that's going to be 1036.6 grams of Na2SO4. And that's what I have. So a little over 1 kilogram of Na2SO4 would make up the 7.3 moles of that, okay? I should have crossed out the units here to show you guys what I'm doing. So moles of sodium sulfate to moles of sodium sulfate here, okay? So I'm just left with grams of sodium sulfate. All right, guys, so that is it for today. I will see you when